Good day, dear learners. Today we shall be looking at modular arithmetics. Modular arithmetics is a special type of arithmetics that only involves integers. It is an arithmetics in which number rounds up when it gets to a particular number. That particular number is what we call the modulo. Take for example an integer 6. Let's say an integer 6. In modular arithmetics, if you divide any integer by 6, any number at all, if you divide it by 6, the possible remainders are 0, 1, 2, 3, 4, 5. Those are the possible remainders when you divide any integer by 6. So these possible remainders are what we call the residues. They are what we call the residues. Let's take for example, we are dividing integer 25. We are dividing it by 6. If you divide 25 by 6, 6 goes here how many times? 6 will go here how many times? 4 times. 4. It will remain what? It will remain 1. It will remain 1. Therefore, this 6 is the modulo, that is, it is the number of operation. Hence, this becomes 1 modulo 6. It means the simplest form of 25 in modulo 6 is equals to 1. That is, 25 is equals to 1 modulo 6. That's the simplest form of 25 in modulo 6. Now let's take it forward. We'll take another example. If we are to reduce, let's say the question says reduce 33 to its simplest form in modulo 4. That is, what is the simplest form of 33 modulo 4? That gives us, now this is going to be 4 multiplied by what will give us something closest to 33. Yes, 4 times 8. 4 times 8, which is 32. Now this is 32, so we need to add 1 to it to make it 33 plus 1. Therefore, that number that we added to it to make it 33 is the modulo. That means 1 modulo 4. Therefore, we can say 33 is equals to 1 modulo 4. Now let's consider the addition and subtraction involving modular arithmetic. Now let's consider the following. We are to evaluate 6 plus 4 and modulo 3. To do this, 6 plus 4 is equals to 10. And 10 in modulo 3 will be 3 times 3 will give us 9 plus 1. That makes 10. 3 times 3, 9 plus 1, that makes 10. So 6 plus 4 will give us 1 modulo 3. We can also take another method to solving this. Let's try this method where we have 6 plus 4 in modulo 3. We can do it separately. 6 in modulo 3 will give us what? That will give us 0. 0 mod 3 plus 4 in mod 3 will give us 1. 1 mod 3. So automatically, if we add 0 and 1 together, we have 1 as 1 mod 3. So that is how we can solve it. Question number 1. Okay, let's try question number 2, which says 11 minus 8. 11 minus 8 in modulo 6. In a simple way, 11 minus 8 will give us 3. Since 3 is less than 6, 3 can form a residue for 6. That means our answer will remain 3 modulo 6. Number 3 says 3 plus 15 in modulo 7. To do this, 3 plus 15, that gives us 18. So in modulo 7, 18 is going to be 7 times 2, which is 14, plus 4. That gives us 18. Therefore, it's going to be 4 modulo 7. Or if you want to take another method, we can say 3 plus 15 in modulo 7. This is 3 in mod 7. It gives us back 3. 3 mod 7 plus 15 in mod 7 will give us 1. 1 mod 7. And if we then add 1 and 3 together, it gives us 4. So 4 modulo 7. To confirm this, let's take a cyclic method. For modulo 7, our possible residue, let's draw a circle here. Now for modulo 7, our possible residue will be 0, 1, 2, 3, 4, 5, 6. Those are our possible residue. Now 3 plus 15 in modulo 7. Let's look at it. We start our counting from 3. 3 plus 15. That means we take 15 steps in the clockwise direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You can see that it stops on 4. So that's another method of confirming it if we are right. Now to the last question, which is 8 minus 22 in mode 9. 8 minus 22 in mode 9. That gives us, if we look at it, this is, if you subtract 22 from 8, that will give us minus 14. Minus 14. And in modulo, we can have a negative number. We can have a negative integer. So here, minus 14 in modulo 9 can be expressed as saying 9 multiplied by minus 2. 9 multiplied by minus 2 will give us minus 18. So how best can we turn minus 18 to minus 14? We can only do that by adding 4. That is, 9 times minus 2 gives minus 18. Minus 18 plus 4 gives minus 14. Therefore, our answer will be 4 modulo 9. 4 modulo 9. Another method to confirm this, let's try the cyclic method again. Now, let's use cyclic method to confirm this. We said 8 minus 22 give us minus 14. Now, because it's minus 14, we are going to count 14 steps in anti-clockwise direction from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We can see that it ends on 4. So that confirms that minus 4 on modulo 9 is equals to minus 14 on modulo 9 is equals to 4. Recall, modular arithmetic involves integers. We are not interested in number of times the modulo go, rather we are interested in the remainder. Remainder always give us the residue that we need for a given modulo. This video, click on the like button and also don't forget to subscribe to the channel Demmy Academy. Till next time we come your way, we say math is fun.